Hi there, and welcome to Aid's Workshop. This is fitting and machining an ER32 collet chuck for my WARCO WM180 lathe. Probably going to be a 2 or 3 part of this, as it got quite involved. Now, normally I record this intro before doing the job and then just get on with it. Not this time. I'm recording this probably about halfway through the project, and I can tell you already it's led me a right merry dance. Now, I've had several cunning plans and changed my mind on the method of doing things several times as well. But I've left all the footage in, all of the footage in as I changed my mind along the way to show you my planning, or perhaps lack of planning, as I went along. So I hope you find it interesting as I struggle to get this right. So let's start with seeing what I want to actually achieve here. ER32, collet, holder, 100mm back plate, and the OD of this is 100mm as well. So the object is to fit that on there. Now, I want this to run as accurately as I can possibly get it. So I need to do a bit of measurement, a bit of setting out first. So my first thought is, let's see how accurately the OD of this runs and how accurately the register on this runs. Bearing in mind that I'm going to have to turn a mating register in the back of the chuck before you even think about the holes to be able to get this located in the correct orientation. So I want to know how good this is on the outside, how good the register is, because I may have to put clearance in it and tap it into spot or something like that. I do not know. So first thing I'm going to do is measure these two, so we'll go on to that next. So there we are for starters. This OD, I've done a bit of Scotch-Brite on it, and I've got 100th of a millimetre out on that OD. That's not bad really, is it? But having said that, I got 100th of a millimetre in play if I jerk on it. So in fact I can go 2 to 0. Or if I really go for it, I may need to do a little bit of bearing adjustment, I don't know, but within 100th of a millimetre, again, probably about 100th of a millimetre. Again, I know the clock is on a slight angle to the register, but 100th, maybe 1.5 hundredths I can see on my clock there. Just trying to take the glare off it. Let's see what I can do. Yeah, 1 to 1.5 hundredths on the register there. Let me just zoom you out so you can see where I am. So my worst reading is 1.5 hundredths of a millimetre. If I end up getting my stock to run in the collet, I don't think I'm ever going to break that barrier of 100th of a millimetre. If I get to 200ths of a millimetre, I think I'm doing pretty well. So let's move on from there. So if I was to turn a register in the back of this, you know, within 100th of a mil, I mean a perfect fit on the register of the lathe, and this was absolutely perfect, the bore to the OD, the best I could hope for was 1.5 hundredths of a millimetre, something like that. Let's have a look and see how good the bore is in relation to the OD. Now I'm hoping it's really good. If it isn't, then I may have to address that. My plan is to put the face plate up on the chuck, clamp this on the faceplate somehow. I have got 3 holes. I'm sure I'll be able to do something with nuts and bolts or what have you, and put this so that the OD is running perfectly true, and then we'll put the clock in the bore and see how the bore of it is in relation to the OD. Let's just make sure everything is spotlessly clean on the back of my faceplate. Little bits everywhere. I'll give it a spray. And that gives me the added advantage, I'm able to degrease that bit of the bench, that bit of the lathe tray as well. That is spotless there now. I can see a few little tiny bits which I'll pick off. Then I'll put a smear of oil on it, just a smear of very clean oil. And then we'll fit it onto the headstock, and I've done exactly the same on the head of the lathe. And hopefully I'll find a way of clamping this after having inspected the face of this to see how well that is running. So put the faceplate up. Now I have used this once before, but only for a rough job. I didn't inspect it at the time. It's been thoroughly cleaned on its rear, on the register. The register on the lathe's been thoroughly cleaned. And this is the standard WARCO faceplate. And it is running out by, I'll give them the benefit of the doubt, 7/100ths. Yeah? 7/100ths of a millimetre at that point. I can't bring my carriage any further out, but 7/100ths at that point. In fact, let's see how far it is out on the outside. I could do this. I've come to the outside edge of the faceplate, and its face is running out by 0.14. What I'm going to try, there is no zero mark or alignment mark for putting this faceplate onto the headstock. The headstock has a 0 in one orientation, so this can go on one of three ways. And I'm wondering if something's out somewhere. The worst it could be, or I could save this by, because I know that the face of the headstock is only running out by 1 to 1.5 hundredths, I may be able to get this a tiny bit better. Pretty much the verdict of this is that I'm going to have to skim the face of this faceplate for future use, and I will mark a 0 on the faceplate so that it always goes onto the head in the same orientation, in the same one of the three ways. So I'm going to flick it around the other two ways it will possibly go on and look for improvement. Tried it in all three orientations. Let's just take the glare off the clock. Maybe zoom you in a bit there. Yeah, I've got 0.14, which is 0.15 was the worst, which is, you know, approximately 6 thou have run out. 0.14 is the best orientation. What I'm going to do now that I've got it in the best orientation, I'm going to skim the face, but I will mark up this orientation so it always goes on whenever I use a faceplate this way. Yeah, some of you to look at, WARCO. The faceplate needs to be matched to the machine, I believe, rather than this just mass-produced piece of cast iron that you've supplied us. Just out of curiosity, I thought I can't do it in the tool post holder, so I'd use a mag stand, but this is Imperial clock, and the OD is running out 12 thou, so that's going to need a skim as well. 12 thou. That is just like, right, okay. That is made in China. So skim on the OD and face the face, and at least I know that that faceplate, I've now marked the register spot. I know that that faceplate, the face of it will be running perfect. So no great worries. It's something you can get over, but one would expect slightly better from a company who's been making these things for many, many years, like WARCO. So yeah, we can put it right, but that's another little hint for WARCO. So a bit of an unorthodox setup this one. I'm stuck right out in the middle of nowhere here. I got my tool post angled over, my compound angled over to try and come out this far on diameter. See if I can get you a bit more light on that. How does that look? So I've just touched it, set my DR out to 0. I'm running nice and slow, I think about 65 RPM, so 63. I've not got the aluminium type tip in this time, it's a standard carbide, and I'm just going to give it a tickle round. So that's first touch. So this should be the final cut. You can see it's just cleaning it up. I've sped it up to 125, now I've got under the skin. And as you can see, I've taken 0.35 of a millimetre from first cut to clean it up. So I'll probably do a spring cut on this one afterwards, just to clean it up, and then Scotch Brite the outside, and then I'll start machining the face. I'm taking a second spring cut because that tool is stuck out so far, and obviously the reason for that is because the bed won't pass, or the two sides of the bed won't pass underneath the faceplate. So I've had to advance the tool. You can see I've tilted the compound out, advance the tool as far as I could advance it on the compound before it jams up on the DRO, and then have a tool, I got a V-tool stuck out as far as necessary to be able to skim the OD. So yeah, I'm just taking a second spring cut. I mean, it is just a scratch on the OD, and the total it's taken is 0.35 millimeters. From my American friends, 0.35, that's roughly 12, 13, 14 thou to clean up that OD to get it concentric. So yeah, I mean the faceplate was 14 thou out, basically. The register itself was a very good fit. You know, you literally had to get it smack on and then, you know, just gently push it back, and you could get it on by hand, you didn't need to hit it or anything. But, so I know the register is good in the back. It's spotlessly clean, and that OD was still running out 14 thou. Now I can see the face is running out. The rings in the face are running out, and I dare say the bore in that faceplate is running out as well. I'm running a bit faster. I'm facing across the face. The intermittent you can hear is the bolt slots. And obviously when you run into the groove it doesn't cut at all. So much to come off the face as you saw earlier. Not much to see really. I'll bring you back when we're done. So I've come up against a bit of a snag. Let me just pull the nut off this ER32 holder. It's actually a really good fit, that nut. Very pleased about that. The bore looks perfectly ground. Back's all ground. OD's ground. Face is ground. Wonderful. What I plan to do is to clamp that on there and clock the front of it in to true. Double check the back of it to true to make sure that that bore is square to the back face, and then run a clock on the OD to make sure that that's true to my concentric center or my central center. If I put clamps out through here, I'm going to have great difficulty clocking it. Again, if this is out in relation to the bore, the OD, I want to be able to machine the OD of this so that when I eventually turn it round and hold it in a forge or chuck, I can clock the OD to do the register. And I know the OD is right to the bore. As long as this face is right, everything's right, I can do the register. So I need a means by which to clamp this on the back here. I can't get anything through the holes. I don't particularly want to drill and tap it. And if I did, I'd have to have it pretty damn concentric to start with so that it would have room to move on my bolts. So what I'm thinking is, it's a blind hole in there, it doesn't go right through, and I'm going to want it to go right through at some stage to be able to feed a bar up through the collet chuck, and ideally it's going to be sort of 20.5, which would be clearance on the biggest stock that I can possibly fit in an ER32. So I think what I'm going to do is clamp this onto the faceplate using a drawbar. So wherever I got it, I've always got plenty of aluminium lying around. I'm going to make a little piece that fits in the back beyond the taper, a little slug with probably an M10 or M12 in it through the centre of it, that drops in the back out of the way of the taper, and then I can use a drawbar right through the tunnel of the lathe and clamp it back tight against the headstock. I can then move it around on that drawbar by tapping it into its central position. So that gives me, I can clock it in, tap it into position, go from there. The other way I could do this is on the external jaws of my 4-jaw, but I don't know with the 4-jaw that it's going to be flat in this orientation. My idea with faceplate, I think is a good idea, and I could do it that way, but I think far simply, if I can hold this on the outside in my 4-jaw, tap it hard back and make sure that this face is running concentric or flat, and then clock up the bore in the 4-jaw. As long as I've got enough sticking out of the jaws to put a clock on to check, at least if it is perfect, that'll be job done. If it isn't, I'm going to have to think again.